Bob sees a stationary cart 8 meters in front of him. He decides to run to the cart as fast as he can, jump on, and roll down the street. Bob has a mass of 75 kilograms, and the cart's mass is 25 kilograms. If Bob accelerates at a steady 1 meter per second squared, what is the cart's speed just after Bob jumps on? So this problem is really a two-part problem. First, well, I know that I'm answering a momentum question because Bob is running towards the cart, jumps onto the cart, and then they move together. So I know that's a momentum problem. But before that, I need to figure out the velocity that Bob has when he jumps onto the cart. And so that's a kinematics problem. So let's write down our givens and finds. So we're given that, let's see, Bob, so the mass of Bob is equal to 75 kilograms. The mass of the cart is equal to 25 kilograms. The distance, so the distance, let's call that instead, let's call that x final. So x final is equal to 8 meters, and the acceleration is equal to 1 meter per second squared. And so I'm going to say for find that we have to do two things. We need to find for part A, we need to find the final velocity. So that means the velocity, Bob starts out from 0 here. Bob starts out from 0 here, and then he's accelerating towards the cart. And so we can find the v final like here. And that v final will be the v initial for the momentum problem when Bob is here just before he jumps on. So, so we're going to call this v final for part A, but then, and this is going to be for the kinematics question. And then for part B, we're going to find v final for the momentum problem. Okay, so let's start over here. So I'm just using the idea that Bob, so we'll draw just a quick little picture. This is Bob. And if I think about a motion diagram, right, so Bob is running this way, and a motion diagram is going to look something like this, right? And so he's increasing speed. He starts out at 0. So we're going to use, since we're given the x final and we're given the acceleration, then we can say the v final squared is equal to v initial squared plus 2ad, or let's call it 2ax. We'll call that x final. So he's starting from x equals 0 and going to here to x final. Okay, and he starts with a 0 initial velocity, so I'll set that equal to 0. And we're looking for v final, so v final is equal to the square root of 2ax final. And we can plug in, so v final is equal to the square root of 2 times 1 meter per second squared times x final is 8 meters. And so that is 16, so I'm going to have v final is equal to the square root of 16 meters per second squared. So v final is equal to 4 meters per second. Okay, so we've got our part A here done. And now when I think about the new problem for part B, I've got Bob here, and I've got my cart here, right? And so this V final that we found in part A, this V final here, is going to be our V initial for Bob just jumping on here. So right before Bob jumps on, this is going to be his V initial for Bob is going to equal 4 meters per second. So that's going to be my V initial. I'm just plugging this in for my new problem as my V initial. And so this is before Bob jumps on, and then this is after. And I'm just representing Bob by like a dot because I'm not good at drawing. And so I know that this right here, the cart is still, so his V is equal to 0. Bob has a V that's equal to 4. And then afterwards, I've got two masses. I've got mass of Bob plus the mass of the cart, and that's going to be moving at some V final. And so that's what I'm looking for. So let's write our momentum equation for part B. So we'll call this part B. And we're going to have our momentum equation is just P initial is equal to P final. So I can write that just from my picture. I know I have the mass of Bob times the V initial of Bob plus the mass of the cart times V initial of the cart is equal to, afterwards they're together, so I can write their masses together, mass of Bob plus mass of the cart times V final, because they're both moving together. All right, so I know my V initial of the cart is 0, and so I just have these two terms. I'm solving for V final, so I can divide both sides by mass of Bob plus mass of the cart, mass of Bob plus mass of the cart. These cancel, so I can now solve for V final is equal to mass of Bob over mass of Bob plus mass of the cart times V initial Bob. Plugging in our numbers is equal to 75 kilograms plus 75 kilograms plus 25 kilograms times 4 meters per second. Well, I don't even need a calculator for this. I can say I know that 75 plus 25 is 100. So 75 over 100, if I want to factor out 25, I would have 3 25s on the top, 4 25s on the bottom, times 4 meters per second. And 4's cancel, and I'm left with 3. So V final is equal to 3 meters per second. And that's how fast Bob and Bob and his cart, right, are traveling together.